Hi everyone, I am Sobi. I will be presenting the topic Prestressed concrete structures. Okay, what is prestressed concrete? Prestressed concrete is basically a concrete in which internal stresses of a suitable magnitude and distribution are introduced so that the stresses resulting from external loads are counteracted to a desired degree. That means an initial compression is given in the concrete before applying external load so that the stress from external loads are counteracted during the service period. This initial compression is introduced by high strength steel wire or tendons located in the concrete section. Yes, here we can see a prestressed member. Yes, this is the tendon which is tensioned before the application of load, and this prestress is transferred to the concrete during the service period, and we will discuss in detail in the following slides. History of prestressed concrete. Eugenio Prestressed is referred as father of prestressed concrete. He was a French structural engineer and he was the major pioneer of prestressed concrete, and he attempted to introduce permanently acting forces in concrete to resist the elastic forces developed under loads, and this idea was later developed under the name of prestressing. And his largest structure was Plogotil Bridge in France, and it is completed in 1930. Here he developed his idea of prestressing. Why do we need prestressed concrete? Before that, let's go back to some basics. We know concrete is good in compression but very weak in tension. That means the concrete tensile strength is only 8 to 14% of compressive strength. It is very less. This is the weak point of concrete, and we have seen after external loading in the bottom part of the beam, a tension zone is occurred. So it tries to be elongated, and guess what? It cracks. So this is why we add some steel bars at the bottom section so that it can resist most of the tension and save concrete from cracking for certain limits. We can explain it with this figure. So here we can see an ordinary RCC beam and it is loaded as shown. And when it is loaded, it deflects downwards, and it started to cracks at the bottom part. We can see the cracks here, and this is our traditional RC structure. But what about some mega structure with larger beam span? You think about a flyover or any other huge bridge over any river where external loading is very high. In the way of traditional RC structure, for these larger spans, we should provide larger depth, which is often too much. That is, for a bridge over a river, that will be no enough space under the bridge for the ship to pass it. That is, the steel reinforcement will not be sufficient to provide the necessary tensile strength. Here, the concept of prestressed concrete. That is, in this case, prestressed concrete is being used. Here we can see prestressed concrete here. See, this is prestressed with this tendons, and when the tendons, the prestress is transferred to the concrete and it deflects upwards, and when it is loaded, it becomes flat or the deflection will be negligible. And this is a crack in ordinary RCC structure. See, this is the crack formed after the external loading. And the concept of PS is not so difficult. In fact, the practice of pre-stressing is very older in our day-to-day life. Yeah. Examples of pre-stressing before the development of pre-stressed concrete. Yeah. First example is force fitting of metal bands on wooden barrels. So this is the wooden barrel with the metal bands. Yeah, this is the metal bands. And this barrel used in olden periods to transport liquids and grains and are tightly bound by metal bands as shown in the figure. And these metal bands are fitted so tightly that it creates a hoop compression around the barrel, and when this barrel is filled with liquid, it exerts hoop tension, and the hoop compression creates by metal bands helps to counteract the hoop tension creates by the fluid. So this is a pre-stressing system. Yeah, we can see the compressive stress created by the metal bands here, and when this barrel is filled with water, it will exert a tension on the barrel, but this tension will be counteracted by the compressive pre-stress by the metal bands. This is a pre-stressing system. Yeah. Second example is pre-tensioning of the spokes in a bicycle wheel. Yeah, a bicycle is very familiar to us. So this is the bicycle wheel, and these are the spokes, and the spokes pulled and tightened as shown in the figure, and the pre-tension is to such an extent that will always be residual tension in the spokes, and when the cycle rides, the weight creates some compression in the spokes, and but it will counteract tension in the spokes. So this is an example of pre-stressing system. Basic concept of pre-stressed concrete. The same concept of wooden barrel and the bicycle wheel is introduced in pre-stressed concrete. We can explain the concept with this figure. Yeah, so this is a beam and which is pre-stressed with the tendon. Then after few days, this tendon pre-stress is transferred to the concrete, and it will deflect upward as shown in the figure, and this upward deflection is called camber, and when the service load is applied, the beam becomes flat or the deflection will be negligible. This is the concept of pre-stressed concrete. And this is an example of pre-stressed structure, Bangalore Metro Rail. For Bangalore Metro Rail, they used pre-stressed girder. Okay. How pre-stressed concrete works? Yeah, now we have the concept of pre-stressed concrete, and we learn why and when should we use pre-stressed concrete. So how does it work? So we can explain it with this diagram. So come to the diagram. So in this diagram, first figure is a non-pre-stressed beam without load, that is normal RCC beam. Yeah, and second figure, it is loaded. Yeah, this is the load, and when it is loaded, it deflects downwards as shown. Yes. In third figure, a tendon is introduced into the concrete and it is tensioned at the both ends. Yeah. Then fourth one, when the concrete harden, the tension in the tension in the tendons are released. Yeah, it is cut out at the both ends. Yeah. In fifth figure, yeah, when the tendons tries to regain their original length, but this is prevented by the surrounding concrete to which the steel is bonded. In that case, the pre-stress in the tendon is transferred to the concrete. So due to this transfer of pre-stress, the concrete deflects upwards. Yeah, as shown in the figure. This is the upward deflection of the concrete. Okay. In the sixth one, so when it is loaded, this stress due to the external load is contracted by the prestress in the concrete. Yeah, that means the concrete become flat or the deflection will be negligible. This is how prestressed concrete works. Okay. Now we can see the prestressing with this diagram. Yeah. In the first diagram, we can see the tensioning of tendon. See, this is the tendon. It is tensioned before the pouring of concrete and it is anchored at the both ends. Yes, we can see it here. And now second figure, the concrete is poured into the mold. Yes. Then when the concrete attains desired strength, the tendons are released and projections are cut out at the ends. Yes. Now the tendons will try to regain their original length, but this is prevented by the surrounding concrete to which the steel is bonded. Yes. So what will happen then? The tendons transfer this tensile strength to the concrete. Due to this, the concrete deflects upwards, forming a camber as shown in the figure. Yeah, we can see it in the figure. Okay. Now when the load is applied, the concrete beam becomes flat or the deflection is negligible. This is how prestressing works. Yeah, one more figure is there. See, in this figure we can see the first one is a concrete beam without prestressing, and it will begin to bend when heavily loaded. See, when the truck moves along the concrete beam, it begins to bend, and also it started to crack here. Okay. Now third one, a tendon is introduced into the beam. Now when it is heavily loaded, no cracks formed. Okay, this makes the beam very strong, prestressing. Okay. Next, methods of prestressing. There are two methods, pre-tensioning and post-tensioning. We will discuss one by one. Okay. First one, pre-tensioning. We can explain pre-tensioning with this figure. Yeah. In pre-tensioning, the tendons are tensioned before the pouring of concrete. Yes. So this is the tendon we can see here, and it is tensioned and anchored at the both ends. After that, the concrete is poured into the mold. Okay, when the concrete attains desired strength, the tendons are cut out at the ends, and now the prestress is transferred to the concrete. Okay, so this is the pre-tensioning of prestressed concrete. This method is developed due to the bonding of concrete and steel tendons, and pre-tensioning is preferred when the structure element is small and is T2 transported, and this method is similar prestressed members are prepared. Okay. Okay, second one, post-tensioning. We can explain it with this figure. In post-tensioning, the tendons are tensioned after the concrete is poured. Initially, the concrete is cast around the sheathing or duct. So we can see duct or sheath here. See, this is a side view. One hole is there. This is the duct or sheathing. So ducts are formed in which the tendons are placed. See, this is tendons which is placed inside the sheathing. After the concrete hardened, the tendons are tensioned by hydraulic jacks and anchored. See. So this is post tensioning. Okay. This method is developed due to bearing, and post tensioning is preferred when the structural element is heavy. In this method, products are changed according to the structure. And cables are used in place of wires, and jacks are used for stretching. Now, materials for prestressed concrete. First one, steel. Second, concrete. In steel, there are three forms: tendons, wire, strands or cables, bars. Okay, so we will discuss one by one. Okay, first one, steel. Ordinary mild steel and deformed bars used in RCC are not used in PSC because their yield strength is not very high. And in PSC, loss of prestress about 20% occurs due to many factors. If mild steel or HYST bars are used, then very little prestress will be left after the losses. High tensile strength steel is used for prestressing. And in addition to the high strength, the steel used in prestressing must have higher ultimate elongation. These are the properties of steel which are used for the prestressing. Okay, these are the ultimate strength values for different diameters of wires. Just go through that. This diameter, different diameters wire available in the market. According to that, we can buy. Now, there are different forms of steel for prestressing. Yeah, first one, wires. The prestressing wire is a single unit made of steel. See, the single unit we can see here. Okay. Now strands. 2, 3 or 7 wires are wound to form prestressing strands. See, we can see here. See, it's wounded. 2, 3 or 7 wires are wound together. Form strands. Okay. Then next, tendons. A group of strands or wires are wound to form a prestressing tendon. See, group of strands wound to form a prestressing tendon. See, this is the tendon. Now bars. A tendon can be made up of a single steel bar. The diameter of a tendon is much larger than a wire. See, single unit. Okay, these are the different forms of steel used in prestressed concrete. Okay, second, concrete. Since high tensile steel is used in prestressed concrete, the concrete used should also be good quality and high strength. And IS 1340-2012 recommends a minimum mix of M40 for pre-tension system and M30 for post-tension system. These mixes have high strength and a high value of modulus of elasticity of concrete, which results in less deflection. The concrete used in PSC should be well compacted. In high strength concrete used for the following reasons. First one, use of high strength concrete results in smaller section. High strength concrete offers high resistance in tension, shear, bond and bearing, and less loss of prestress occurs with high strength concrete. So these are the properties of concrete used in prestressing. Advantages and limitations of prestressed concrete. Yes. First, let's see advantages. So, concrete remains uncracked in PSC, and reduction of steel corrosion, increase of durability, high span to depth ratio, less dead load, more economical. Now, limitations. Skill technology. Use of strength material is costly. there is additional cost in auxiliary equipment, a need for quality control and inspection. So these are the advantages and limitations of pre-stressed concrete. Okay. So these are the reference book for pre-stressed concrete. You can note the reference books and IS 1343 2012 IS code. We can watch a small animation about pre-stressed concrete. This is normal RCC beam, but it is not sufficient to provide necessary tensile strength. In this case, pre-stressed concrete is being used. In pre-stressed concrete, the tendons are tensioned and concrete is poured. When concrete hardened, tendons cut out at both ends as shown. When external load applied, the stress due to this external load is counteracted by the pre-stress of concrete. Prestressed concrete is that compressive stresses induced by the high strength steel tendons in a concrete member before loads are applied. This will balance the stresses imposed in the member during the service period. Construction of roofs, floors and walls, and construction of bridges. Two types of prestressed concrete we discussed already: pre-tension concrete and post-tension concrete. In pre-tension concrete, the tendons are tensioned before the pouring of concrete. Now concrete is poured into the mold. When concrete attains desired strength, tendons are cut out at both ends. Prestressed impart into beam through bond action. In post-tension concrete, the tendons are tensioned after the concrete is poured. The concrete is casted with a sheathing or duct. You can see here, and tendons are placed inside the sheathing. When concrete hardened, the tendons anchored at both ends using hydraulic jack. In bonded type tendons, the duct is grouted with sufficient slurry. In unbounded type of tendons, grouting is not necessary.